Hey everybody, here are the notes for homework number 16, part 1, the trigonometry part of it, special angles and a couple other things. So there are three special angles, 30 degrees, 45 degrees, and 60 degrees. And we can find all six trigonometric functions of these angles, and they have very specific values. So we don't want to use decimal approximations or a calculator. We're just going to do these kind of the old-fashioned way. I'll point out, so we'll start with 45 degrees. And 45 degrees, if you change that to radians, it's equal to pi over 4 radians, right? Just a reminder, take 45 degrees. I don't really love this pen here. Pens, take 45 degrees. There we go. And multiply it by pi over 180 degrees. You end up with 45 pi over 180, which reduces to 5 pi over 20, which reduces to pi over 4. So 45 degrees, same as pi over 4 radians. And if you draw a square with a side length of 1 and cut it in half diagonally, this angle here is half of 90 degrees, which is 45 degrees, or half of pi over 2 radians, which is pi over 4 radians. And both of these angles are 45 degrees. So this is a 45, 45, 90 triangle. And this side is 1, and this side is 1. And if we call this side x for a minute, we can find the length of that side using the Pythagorean theorem. So we have that 1 squared plus 1 squared equals x squared. 1 squared is 1, 1 plus 1 is 2. So x squared is equal to 2. So the length of that hypotenuse, sorry, the square root of 2 is equal to x. So this side here is the square root of 2. So if we want to find sine of 45 degrees, it's going to be the opposite divided by the hypotenuse, which is going to be 1 over root 2. Typically for trigonometric functions, we do rationalize denominators. So I'm going to multiply this by root 2 over root 2 and get root 2 on top. And root 2 times root 2 is 2 on the bottom. So sine of 45 degrees is the square root of 2 over 2. Similarly, cosine of 45 degrees is the adjacent over the hypotenuse, which is also the square root of 2 over 2. I'm going to start with saying it's 1 over root 2, right? It's 1 over root 2, but then we know that that's the same as that, so that's just root 2 over 2. And actually, this is probably one of the things I remember the most about this angle, 45 degrees or pi over 4 radians, is that sine of 45 degrees and cosine of 45 degrees have the same value. They're both the square root of 2 divided by 2. Tangent of 45 degrees is going to be the opposite over the adjacent, which is 1 divided by 1, which is just 1. And then for the other three reciprocal functions, I would really just do the reciprocal. So cosecant of 45 degrees is going to be the reciprocal of 1 over root 2, which is root 2 divided by 1, or just the square root of 2. Or I could use the triangle, say it's going to be the hypotenuse divided by the opposite. Secant of 45 degrees is going to be the reciprocal of cosine of 45 degrees, so it's also going to be the square root of 2. And cotangent of 45 degrees is going to be the reciprocal of tangent of 45 degrees, which is going to be 1 divided by 1, which is 1. So if someone asks you to find the six trig functions of 45 degrees, here's what they are. Sine of 45 degrees is root 2 over 2. Cosine of 45 degrees is root 2 over 2. Tangent of 45 degrees is 1. And the reciprocal functions have their values. It's probably worth memorizing what this 45, 45, 90 triangle looks like, where the sides are 1, 1, and the hypotenuse is root 2. Let's look at the other triangle. Let me make sure this feels like this looks just a little bit off kilter here. Let's see. Okay. So that's one of the three angles. Let's look at the other two. So the other two angles we're going to get by taking an equilateral triangle, side length of 2. You can actually make the side length whatever you want, but 2 is convenient. And then we're going to cut it in half down the middle. I should point out that each of these angles here is 60 degrees. And so is that angle up there. And then when we cut it in half this way, we get a 60-degree angle here and a 30-degree angle up here, and the 90-degree angle right there. You could also, if you prefer, label it with radians, right? That 60-degree angle is pi over 3 radians. That 30-degree angle is pi over 6 radians. And then we should label the side lengths. So this hypotenuse has a length of 2. This base here, where we're cutting this base in half, it's going to have a length of 1. And then let's find the height there. So we're going to say that 1, right? So Pythagorean theorem, that side is 1. That side is x, that side is 2. So 1 squared plus x squared equals 2 squared. X squared equals 4 minus 1. So x is going to equal the square root of 3. One way I remember how this triangle looks is that the smallest side is opposite the smallest angle, the largest side is opposite the largest angle, and the medium side, because the square root of 3 is about 1.73, is opposite the medium angle. 60 degrees is between 30 degrees and 90 degrees, and the square root of 3, which is about 1.7, is between 1 and 2. And it's always true for triangles. The smallest angle is always opposite the smallest side, and the biggest angle is always opposite the biggest side, and the medium angle is always opposite the medium side. Always true. So then we're going to do the same sort of thing. We're going to find sine of 60 degrees or sine of pi over 3. Same thing, right? 60 degrees is pi over 3 radians. So we're going to just use this special 30, 60, 90 triangle to find all the trig functions. So sine of pi over 3 is going to be opposite of hypotenuse, so the square root of 3 over 2. Cosine of pi over 3 is going to be 1 over 2. Tangent of pi over 3 is going to be root 3 divided by 1. Divided by 1, you should just say, we know divided by 1 doesn't change anything. And then cosecant of pi over 3 is going to be the reciprocal of that, so that's going to be 2 over root 3. And again, when you have a radical in the denominator, we are expected to rationalize that. So multiply by root 3 over root 3 to get 2 root 3 over 3. Secant of pi over 3 is going to be the reciprocal of cosine, which is going to be 2 over 1, which is just 2. And cotangent of pi over 3 is going to be the reciprocal of tangent of pi over 3, which is going to be 1 over root 3. And then if we multiply by root 3 over 3, we're going to get root 3. So if we multiply by root 3 over root 3, we're going to get root 3 over 3. So many 3's. And then we use the same triangle for the other special angle, which is 30 degrees or pi over 6 radians. So look at this triangle. I do, for whatever reason, I do like to orient it so that the angle I'm taking the trig functions of is over in this kind of left corner here, but it's definitely not required. And again, the side opposite 30 is the smallest side, opposite 90 is the biggest side, and opposite 60 is the medium length side. Same deal. Now sine of 30 is 1 over 2. Cosine of 30 is root 3 over 2. And tangent of 30 is 1 over root 3. And we know from before that 1 over root 3 is equal to root 3 over 3. And then cosecant of 30 is the reciprocal of that, so it's 2. Secant of 30 is the reciprocal of root 3 over 2. And we saw last time that the reciprocal of root 3 over 2 is 2 over root 3, which then simplifies as 2 root 3 over 3. And cotangent of 30 is the reciprocal of 1 over root 3, which is just root 3. I will also point out that for these two angles, 30 degrees and 60 degrees, which are complementary angles, right, because they add to 90 degrees, the values of the trig functions essentially interchange, right? Sine and cosine have interchanged values. And tangent and cotangent have interchanged values. And secant and cosecant have interchanged values. And that's not a coincidence. That always happens for co-functions, sine and cosine, tangent and cotangent, secant and cosecant of complementary angles, because essentially the angles are going to appear in the same triangle, right? 30, right? This is a 90-degree angle, which it's going to be. The other two angles have to add up to 90 degrees, which is the definition of being complementary. So these are the three special angles that we are expected to be able to find all the trig function values of. And I would probably recommend, no, definitely recommend memorizing this 30, 60, 90 triangle with the side lengths of 1, 2, and root 3, and this 45, 45, 90 triangle with side lengths of 1, 1, and root 2. And just like in the other triangle, the smaller angles are opposite the smallest side, and the bigger angle is opposite the biggest side, right? Square root of 2 is about 1.4, which is definitely bigger than 1. Okay. Couple other things. Quadrants. So we haven't really talked about this, but the XY coordinate system is broken up into 4 quadrants. Quadrant 1 is the one where both X and Y are positive. And then we go counterclockwise to name the other quadrants. So quadrant 2, quadrant 3, quadrant 4. In quadrant 1, and again, this is also right, talking about how the angle is measured. We measure from the positive x-axis. So in quadrant 1, the angles go from 0 degrees to 90 degrees. So right here we say this is theta equal to 0 degrees. Up here, this is theta equal to 90 degrees. So if you're in quadrant 1, your angle is between 0 degrees and 90 degrees, which is the same as saying your angle is between 0 radians, and pi over 2 radians. In quadrant 2, going from here to here, your angle is between 90 degrees and 180 degrees. Over in quadrant 2, your x values are now negative because you're left of the y-axis. So x is actually negative over here. Y is actually positive over here. Oh, positive, bigger than 0. Your angle, as I said, is between 90 degrees and 180 degrees. Or in radians, your angle is between pi over 2 radians and pi radians. Let's continue on. In quadrant 3, going from 180 degrees to 270 degrees. Now, both x and y are negative because you have, right, your left and down. So x is less than 0. Y is also less than 0. Your angle is between 180 degrees and 270 degrees. Or if you prefer, your angle is between pi radians and 3 pi over 2 radians. I guess I could also write that this is equal to 0 radians. This is equal to pi over 2 radians. This is equal to pi radians. This is equal to 3 pi over 2 radians. Finally, one full revolution gets you back to 360 degrees or 2 pi radians. So to be over here in quadrant 4, well, now x is positive, but y is negative. Your angle is between, as I said, 270 degrees and 360 degrees, or between 3 pi over 2 radians and 2 pi radians. We talk about angles being in a specific quadrant, because if you draw an angle, and I think I say this on the next page, but I'm going to say it here as well. You draw this angle of 150 degrees by starting at the positive x-axis and then going counterclockwise until you get to that angle. So that angle right there would be drawn like that. That's an angle of 150 degrees. And that angle terminates in quadrant 2. So we would say that theta equals 150 degrees is in quadrant 2. We don't say all the words. Like you could technically you're saying it's terminating in quadrant 2, but we just say it's in quadrant 2. Similarly, 225 degrees is bigger than 180, but not as big as 270, so it's going to be in quadrant 3. 60 degrees is between 0 degrees and 90 degrees, so that's going to be in quadrant 1. 300 degrees is more than 270, but less than 360, so it's going to be in quadrant 4. Sorry. So that's kind of the idea. An angle that isn't 90 or 180 or 270 or 360 is going to terminate in a quadrant. Those other angles, 90, 180, 360, and 270, aren't in any quadrant. They're called quadrantal angles, and they don't live in any quadrant because to be in a quadrant, you have to be between those values, not actually equal to those values. There is a point to all this. We're getting there, I promise. It's just a slow build up here. So last thing we'll say before we're really getting to the point is reference angles. So when we draw an angle in the standard position, which I just did, we start at the positive x-axis, which is the right side over here, and then we move counterclockwise to the terminal ray, which is just where the angle ends. So I'm going to draw an angle of theta equal to 150 degrees again. It's essentially going to go like this. I'm going to start here until I get all the way over there. And this angle is 150 degrees in quadrant 2, or terminating in quadrant 2. Now, this is really important. The reference angle is the acute angle, meaning an angle between 0 degrees and 90 degrees, measured from the terminal ray to the nearest x-axis. So I don't want to go all the way back this way or all the way around this way. I want to go just right there. That angle, well, if I went all the way around to the left side here, that's 180 degrees total. So this red angle here is going to be the difference between 180 degrees and 150 degrees. So here, we'd say that the reference angle, which we often abbreviate as RA, for 150 degrees is going to be 180 degrees minus 150 degrees, which is 30 degrees. Let's throw another example in there real quick. If my angle was, say, 225 degrees, then I should use a different color, but I don't have another color. So I'll just draw it over here real quick. If my angle was 225 degrees, then I would go all the way around to here, ending in quadrant 3. So there's my actual angle. Oops, sorry, you can't quite see that. There's my 225-degree angle. And then the reference angle, I'm still measuring back to the x-axis here. There's my reference angle. and it's going to be the difference between my actual angle, 225 degrees, and the angle measure of the x-axis, which in this case is 180 degrees. So here my reference angle. Now notice in the previous one, our reference angle was 180 minus 150 to get an angle of 30. Here my reference angle is going to be 225 minus 180. I have to subtract in whatever direction gives me still a positive angle at the end of the process. So reference angle should always be positive. Let's look at a few more examples. So find the reference angles for the following angles. And really part of finding the reference angle is figuring out kind of what quadrant or angle terminates in. And I'm unfortunately not seeing an angle. So I actually want to start with a different example from all of these. I'm actually going to start with theta equal to, let's say, 330 degrees. So I want to show one more example that's in quadrant 4. So for this angle here, 330 degrees, right? We know it's more than 90, it's more than 180, it's more than 270, but it's not more than 360. So it's going to look something like this. My picture is probably not great. So that's my 330 degree angle. And if I went all the way around, right, because if I'm going to measure to the nearest x-axis, I'm going to go that way to the nearest x-axis. That's my reference angle. And it's going to be the difference between the actual angle, 330, and the angle for the x-axis there, which is a full 360. So here my reference angle is going to equal 360 minus 330, which is going to be 30 degrees. You don't have to show all this work. Like if you can just see that the reference angle is 30 degrees, that's totally fine. But it's good to kind of think about what's being subtracted from what. Let's do a few more examples. And really, the easiest way to kind of think about these, at least at first, is to draw them. So for 140 degrees, I'm thinking, okay, quadrant 2. There's my 140 degree angle. I'm trying to get to 180. The difference is going to be 40 degrees. Right, that's 180 minus 140, which is 40 degrees. So here my reference angle is 180 degrees minus 140 degrees, which is 40 degrees. For 208 degrees, I know I'm going into quadrant 3. Right, bigger than 180, less than 270. I don't love that there. So then here's my reference angle, again, measured to the closest x-axis. Well, it's going to be the difference between 208 and 180. So it's going to be this time 208 degrees minus 180 degrees, which is going to be 28 degrees. You can also do this in radians. So I don't think you should, and I would recommend not changing it to degrees. We should just keep it in radians. So I'll point out that on the unit circle, sorry, we haven't really talked about the unit circle. But going around the circle here in the quadrants, the quadrantal angles are 0 radians, pi over 2 radians, which equals 90 degrees, pi radians, 3 pi over 2 radians, and this is also 2 pi radians. So what I often do if I have something weird like this is I actually kind of think about all these in terms of that denominator. So if I multiply pi over 2 by 6 over 6, it's 6 pi over 12. Pi times 12 over 12 is 12 pi over 12. And importantly, 3 pi over 2 times 6 over 6 is going to be 18 pi over 12. So 19 pi over 12 is just a little bit bigger than that. When I draw this angle, I'm going to go all the way around over into quadrant 4. So to find the reference angle here, it's going to be the difference between 2 pi and my angle, which is 19 pi over 12. So my reference angle here is going to be the difference between 2 pi and 19 pi over 12. And so it should always be the bigger angle minus the smaller angle. 2 pi is definitely the bigger angle because it's further around the circle. So it's going to be 2 pi minus 19 pi over 12, which is going to equal 24 pi over 12 minus 19 pi over 12, which is going to equal 5 pi over 12. Which makes sense, right? Because if I go 19 pi over 12 and then another 5 pi over 12 is what's going to get me to 24 pi over 12, which is equal to 2 pi. It's a little bit weirder when the angles are negative. So if your angle is negative, that means you're going clockwise instead of counterclockwise. So if I go in the clockwise direction, I know that normally 5 pi over 6 would end up like right about there. And I should say, right, 5. So I'll point out, right, if this is pi over 2, which is equal to 3 pi over 6, and this is pi, which is equal to 6 pi over 6, then 5 pi over 6 would get me to almost pi. So negative 5 pi over 6 is going to get me almost to negative pi. So I'm going to go this way. So there's my angle of negative 5 pi over 6. And these ones I feel like you kind of are easier just to kind of think out. So I'm trying to find this angle, and then to get from negative 5 pi over 6 to negative pi, the difference is pi over 6. The subtraction always feels kind of weird. Technically, the right way to calculate this reference angle here is it's going to be, right, so this angle here is, if I'm going clockwise, it's going to be not positive pi, but negative pi. And the reference angle should be the bigger angle minus the smaller angle. So in this case, it's going to be the less negative angle minus the more negative angle, which is going to be negative 5 pi over 6 plus 6 pi over 6, which is just going to be 1 pi over 6. Or you can just see that it takes another pi over 6 to get there. But it does have to be a positive angle. So if you do the subtraction and getting negative pi over 6, you should just change it to positive pi over 6, because it should always be positive. Let's do the same thing for negative 250 degrees. So for negative 250, I'm going to start here and I'm going to go negative 90, negative 180, not quite all the way to negative 270. So I'm going to draw that terrible thing right there. So there's my angle of negative 270 degrees, and I'm trying to get back to the closest x-axis, which is going to be negative 180 degrees. Right, going clockwise, it's negative 90, negative 180, negative 270, negative 360, which is, again, it's kind of weird, but negative angles are a thing. So I'm going to find the difference. And again, my reference angle here is going to be the less negative angle minus the more negative angle. And I wrote negative 270. It should have been negative 250. Sorry about that. Terrible. So it's the less negative angle, negative 180 degrees, minus the more negative angle, negative 250 degrees. That's going to be negative 180 plus 250, which is going to be positive 70. Or you could just say 250 minus 180 is going to give you an angle of 70. You're really just looking for the difference. It doesn't matter if you get there in a slightly different way. So this reference angle here is 70 degrees. And even though it's right, even though you might want to call it negative 70 degrees, because technically you're thinking about measuring it in the clockwise direction, reference angles always have to be positive. It's just a difference between two angles. I will point out, we're always measuring to the x-axis, right? We're always measuring from our angle to the x-axis, to the x-axis, to the x-axis, every time. Never, never, never to the y-axis. So here, it would be incorrect to say that the reference angle was 20 degrees, right? We're not measuring to the y-axis, we're measuring to the x-axis. Okay, last one here, 23 pi over 7. This is a hyperextended angle, meaning it's more than 1/4 revolution. So if we think about this, here's my 0, my pi over 2, my pi, my 3 pi over 2. I'll point out that when we do 23 pi over 7, well, pi is equal to 7 pi over 7, and 0 or 2 pi is equal to, if you multiply by 7 over 7, 14 pi over 7. So I'm doing one full revolution, getting the 14 pi over 7. And then if I do another half revolution, which is another pi or 7 pi over 7, that's going to get me to 21 pi over 7. Right? 3 pi is a full revolution and half a revolution. That's going to be 21 pi over 7. So I'm going to go a little bit further than that. So here's my reference, my actual angle of 23 pi over 7. I'm trying to get back to that axis there, which isn't just pi, it's 3 pi. So maybe the right way to do this is to first just make the angle less than a full revolution. So you could say, first I'm just going to subtract off of 2 pi. So 21 pi over 7 minus 2 pi is 21 pi over 7 minus 14 pi over 7. Sorry, not 21, 23, apologies. 23 pi over 7 minus 2 pi is 23 pi over 7 minus 14 pi over 7. which ends up being 9 pi over 7. And then if I do 9 pi over 7, that's just here, and then I have to get back to pi, so I have to subtract the pi. And I'm doing kind of bad math here. I apologize. That's kind of terrible. My reference angle is going to equal 9 pi over 7, my actual angle, minus 7 pi over 7, which is 2 pi over 7. Which again shouldn't be terribly surprising, because when we found this angle, we went all the way to 21 pi over 7, and then we went 2 pi over 7 more. So, say it again, reference angles are just the measure of the angle from your terminal ray to the closest x-axis. It's often going to be over here, but occasionally it's over here as well. So sometimes it's 2 pi minus your angle, or 360 minus your angle. Sometimes it's your angle minus pi, or your angle minus 180 degrees. Sometimes it's 180 degrees minus your angle, or sometimes it's, yeah, I didn't have another one with pi, but yeah. So it's always just measuring to the x-axis, which is either an angle of 180, which is pi radians, or 360, which is 2 pi radians. Okay, so the reason we're doing all this is because then we can use all of this to find the trig functions of angles whose reference angles are special angles. So for example, we can use this to find sine of 7 pi over 6, cosine of 7 pi over 6, tangent of 7 pi over 6. And here's how we're going to do it. So first we're going to draw the angle in the standard position. So, sorry, wrong pen here. And that's why we talked about what quadrant things are in, because we know that this is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians. We know that 7 pi over 6 is just a little bit bigger than 1 whole pi, right? 7/6 pi is slightly larger than pi, right? Pi is equal to 6 pi over 6. So 7 pi over 6 is going to be right about there. Here's our angle, 7 pi over 6. Find the reference angle. So we're going to go back to the nearest x-axis. That angle is going to be your reference angle. So here it looks like our reference angle is going to be 7 pi over 6 minus 6 pi over 6, which is just pi over 6. Not terribly surprising. Now we're going to draw the associated special triangle, not angle. Sorry about that, triangle. So what we're going to do here is we're just going to draw the triangle right here. So this is a pi over 6, 90, pi over 3. Let me draw this. Let me draw it again over here just so I can make it look a little bit nicer. I feel like it's kind of getting a little bit messed up. So, right, here's my special triangle. And this side is, this angle is pi over 6 radians. This angle is pi over 3 radians. And this is a right angle here. And then we can label the lengths of the sides. We know that the smallest angle is opposite the smallest side. The biggest angle is opposite the biggest side. And the medium angle is opposite the medium side. However, we're now going to think about the fact that we're in the third quadrant and x is actually negative and y is actually negative. The hypotenuse is always positive. So then we're going to find the values. It looks like sine of 7 pi over 6, which is this whole angle here, is going to be, well, it's going to be the opposite over the hypotenuse. So it's going to be negative 1/2. And cosine of 7 pi over 6 is going to be the adjacent over the hypotenuse, which is going to be negative root 3 over 2. And tangent of 7 pi over 6 is going to be the opposite over the adjacent, which is negative 1 over negative root 3, which is going to simplify to positive, and we're going to rationalize as root 3 over 3. So this is kind of the long way of doing it, but it does work. We're going to find a shorter way in just a second here. But that's kind of the idea, is that you're just using the special triangles we already have and the reference angle we found, which is going to be one of those special angles, and then using the associated triangle to find the values asked for. Let's look at another example, and we're going to do this next one 2 ways. So for the next one, we're going to find cosine of 3 pi over 4, sine of 3 pi over 4, and tangent of 3 pi over 4, and we're going to do this in 2 ways. And we're actually going to do it the shorter way first. So The shorter way, which is what we're going to kind of, shorter way first, yeah. We're going to kind of move forward is we're just going to find both the reference angle and the quadrant. I still like drawing a picture though. So 3 pi over 4, well, 3 pi over 4 is going to be between pi over 2, which is equal to 2 pi over 4, and pi, which is equal to 4 pi over 4. Right? 3 pi over 4 is less than pi, so we know it should be somewhere in quadrant 2. Drawing is going to look about like this. So here's another way to think of this. In quadrant 2, we are going to say that sine is positive and the other two trig functions are negative, which makes sense because in quadrant 2, the opposite part, right, if we actually draw the triangle there, the opposite side will be a positive value because it's a positive y thing, but the adjacent side will be a negative x value. There's actually a whole kind of mnemonic device about this, which says the following. We could say that all students take calculus, meaning that in the first quadrant, all trig functions are positive. In the second quadrant, sine is positive and tangent and cosine are negative. In the third quadrant, tangent is positive and sine and cosine are negative. And in the fourth quadrant, cosine is positive and sine and tangent are negative. All students take calculus. So what this tells us is that if we know our angle is in quadrant 2, we know that sine is going to be positive, and we know that the other two trig functions, cosine and tangent, are going to be negative. So I know that, watch this for a second, that sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is also root 2 over 2. And tangent of pi over 4 is equal to 1. But now since my angle is in quadrant 2, I know that sine of 3 pi over 4 is positive root 2 over 2. Cosine of 3 pi over 4 is negative root 2 over 2. And tangent of 3 pi over 4 is negative 1. We're kind of not talking about the other three reciprocal functions because we don't really have to, but if we wanted to, we could find that cosecant of 3 pi over 4 was positive root 2, secant of 3 pi over 4 is negative root 2, and cotangent of 3 pi over 4 is negative 1. We could also do this by drawing the triangle. So like we said here, right, our reference angle here is pi over 4, which I guess I didn't really mention. No, I did say our reference angle is pi over 4. That's why we use pi over 4 here to find the values, and then we use the quadrant to find the signs. And then we could draw the triangle. So the triangle has the sides of negative 1, 1, root 2. Again, I'm really just going back to my special triangle from the beginning, right? The angle was 45 degrees, the sides were 1, 1, and root 2. I'm just appropriately changing the sign. We're going left, that's a negative. We're going up, that's a positive. So we could also look at this and say, oh yeah, sine of 3 pi over 4 is going to be opposite over hypotenuse, which is 1 over root 2, which is root 2 over 2. Cosine of 3 pi over 4 is going to be adjacent over hypotenuse, and negative 1 over root 2 is negative root 2 over 2. And tangent of 3 pi over 4 is going to be opposite over adjacent, and 1 over negative 1 equals negative 1. So that's how we're getting these three values, or it's another way of getting those three values. So kind of the typical way of doing this to do hopefully as little work as possible is to first identify the quadrant the angle's in, which will tell us what the signs of the trig functions are going to be, and also to identify the reference angle, which will tell us what the values of the trig functions are going to be. Let's look at another example. So let's find all 6 trigonometric functions of theta equal to 5 pi over 3. So I think it helps to draw the picture, at least to find where the angle is. So 5 pi over 3 is going to be, let's see, it's bigger than 3 pi over 3, which is pi. It's bigger than 3 pi over 2. In fact, I do think it's worth labeling these angles 0, pi over 2, pi pi, 3 pi over 2. It's actually bigger than that as well. It's going to be right about there. How do I know this? Well, if I think about this, right, if I get a common denominator, I could think of this as 10 pi over 6. This is going to be 3 pi over 6, 6 pi over 6, 9 pi over 6. So it's a little bigger than 9 pi over 6, but it's less than 2 pi, which is 12 pi over 6. So then my reference angle, well, let's see, my reference angle is going to be the difference between 2 pi and my angle, 5 pi over 3, which is going to be 6 pi over 3 minus 5 pi over 3, which is pi over 3. The reference angle here is pi over 3. My quadrant is quadrant 4. And quadrant 4, I know that cosine of my angle is going to be positive, and the other two primary trig functions, sine and tangent, are going to be negative. This also means that the reciprocal function secant will be positive, and these reciprocal functions, cosecant and cotangent, will be negative. So whatever one function is doing, its reciprocal also has the same sign. So then I'm either going to remember or think of my special triangle for the angle pi over 3. Pi over 3 is the medium angle, and the other angle over here, which is 30 degrees, where pi over 6 is the smallest angle. Smallest angle, small side. Biggest angle, biggest side. Medium angle, medium side. So then I know that sine of 5 pi over 3, right, that's the angle we're looking at. Well, I know that sine of pi over 3 would be root 3 over 2. So the sine of 5 pi over 3 is going to be negative root 3 over 2. Cosine of 5 pi over 3, well, I know it's going to be positive. And tangent of 5 pi over 3, I know it's going to be negative. Cosine of pi over 3 is 1/2, so cosine of 5 pi over 3 is positive 1/2. Tangent of 5 pi over 3, tangent of pi over 3 is root 3 over 1, so tangent of 5 pi over 3 is going to be negative root 3 over 1. And then, whoops, sorry, you can't quite see that, apologies. And then the reciprocal functions, we just take the reciprocal. So cosecant of 5 pi over 3 is going to be negative 2 divided by root 3, which rationalizes as negative 2 root 3 over 3. Secant of 5 pi over 3 is the reciprocal of 1/2, positive 1/2, which is positive 2. And cotangent of 5 pi over 3 is going to be the reciprocal of negative root 3, which is going to be negative 1 over root 3, which is going to be negative root 3 over 3. So every trig function and its reciprocal will always have the same sign: negative, negative, positive, positive, negative, negative. And then we find the values by just using the special triangle with the correct reference angle. Yeah, let's do a couple more and then we will move on. So let's find cosecant of 19 pi over 6. So 19 pi over 6, let's see, where is that going to land us at? Here's pi, which is 6 pi over 6. 2 pi, which is 12 pi over 6. 3 pi, which is multiplied by 6 over 6, 18 pi over 6. So just one more pi over 6. So there's my angle, 19 pi over 6. And my reference angle, it's pretty easy to see, I think, that my reference angle is just a pi over 6. Because my reference angle is just the difference between 19 pi over 6 and 18 pi over 6. Just pi over 6. So then we know that the special triangle for that is going to be this, right, pi over 6 here. That's the smallest angle, so the 1 goes there. The 2 is always the hypotenuse, and the other medium side is root 3. And since we're in quadrant 3, we know that tangent is going to be positive, and sine and cosine are going to be negative. Cosecant is the reciprocal of sine, So here's what I would write. I know that sine of pi over 6 is equal to 1/2. So then I know that sine of 19 pi over 6 is equal to negative 1/2 because sine is negative in quadrant 3, and my angle terminates in quadrant 3. And finally, cosecant of 19 pi over 6 is going to be the reciprocal of that, which is going to be negative 2 over 1. That's the whole deal. Same deal over here. Let's find secant of negative 9 pi over 4. So first and foremost, let's find the reference angle and the quadrant. So let's see. Negative 9 pi over 4. So here's negative pi over 2, negative pi. So negative pi is negative 4 pi over 4. Go another full half, and that's going to be negative 2 pi, which is negative 8 pi over 4. I'm going to go one more pi over 4, which is 45 degrees, to get that angle right there. So here's my, sorry, I kind of do that kind of weird. Here's my negative 9 pi over 4. And my reference angle is clearly pi over 4, or 45 degrees. So I know that, okay, and I'm drawing this kind of strangely, but fine. So my reference angle is pi over 4, sides are 1, 1, and root 2. Looking for secant, I know the secant is the reciprocal of cosine. I know that cosine of pi over 4 is adjacent over hypotenuse, which is 1 over root 2, or root 2 over 2. In quadrant 4 over here, I know that cosine is still positive, right? Again, all students take calculus. Cosine is positive in quadrant 4. So cosine of negative 9 pi over 4, which does land us in quadrant 4, is going to still be positive root 2 over 2. And then secant of that same angle, I'm going to take the reciprocal of this, but I'm going to be smart. I'm not going to write 2 over root 2. I'm going to take the reciprocal of that and write root 2 over 1, or just root 2. And it is positive. Cool. Last thing in this first part. Sometimes we don't actually know what the angle is, but we're given some values. So we can be given that sine of theta equals negative 3/5, tangent of theta is positive, find cosine theta. So first, find the quadrant. Well, sine is negative, so we can't be here and we can't be here. Tangent is positive, so we can't be here. So we have to be here. So we're in quadrant 3, where cosine happens to be negative, because tangent is positive, cosine is negative, so is sine. Now we're going to draw a triangle that meets the criteria. And I usually ignore the sign, meaning I ignore the positive or negativeness. So I know the sine of theta, I'm just going to ignore the negative, is the opposite over the hypotenuse, which I'm thinking of as being as 3 over 5. You could write negative 3 over 5 if you prefer, but I kind of like to think of my distances as being positive. And I'm going to find this last side here by using the Pythagorean theorem. So x squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. X squared equals 25 minus 9, which is 16. X equals the square root of 16, which is 4. So this side is 4. So I'm going to find cosine of theta by using the triangle. So it's going to be adjacent over hypotenuse, which is 4 over 5. And then we know, since we're in quadrant 3, cosine of theta has to be negative. That's what we're looking for. Last one on the next page here. Same kind of problem. Given that cosine theta equals negative 5, 6, and sine of theta is negative, I think we're in quadrant 3 again. Find tangent theta. Let's check. So again, all students take calculus. If cosine is negative, we can't be here and we can't be here. If sine is also negative, we can't be here. So again, quadrant 3. Sorry for the unoriginality of my question here. So then we're going to draw the triangle. So cosine of my angle, and I'm just going to say, I'm going to ignore the negative sign. It's 5 over 6, which is going to be adjacent over hypotenuse. So the adjacent side is 5, the hypotenuse side is 6. We don't know the third side. Pythagorean theorem again, 5 squared plus x squared equals 6 squared. 25 plus x squared equals 36. X squared equals 36 minus 25 is 11. X is just the square root of 11. We don't do any decimal approximation or anything else. You're just stuck with square root of 11. So then we're trying to find tangent of theta. So tangent of theta should equal the opposite over the adjacent. So it's the square root of 11 over 5. And since we're in quadrant 3, tangent should be positive. You don't really need the positive sign there, but I kind of like it to really emphasize the fact that I know what my answer is. Yeah, so for problems like this where you don't know what the angle actually is, but you know some information, the process typically is to figure out the quadrant so you know what sign your answer is going to be. Right, we were in quadrant 3 and we were asked to find tangents, our answer ended up being positive, and then use the given value to draw two sides of a triangle. And you have to know, like, if it's cosine, it's adjacent over hypotenuse. If it's sine, it's opposite over hypotenuse. If it's tangent, it's opposite over adjacent. And then you can, what's the word I'm looking for? You can use all that information to find the given value. Let's just do what I would encourage you all to do, kind of paper here, yes, paper here, right on. So I would say try this stuff on your own. So I would say, given sine of theta equal to 5 over 7 and cosine of theta less than 0, find, let's say, cotangent of theta. So again, pause the video, try it yourself. Great. And now let's do it. So sine of theta is 5 over 7. So there's theta, opposite over hypotenuse, right? Sine of theta is opposite over hypotenuse, which is 5 over 7. I'm going to find this to the side. X squared plus 5 squared equals 7 squared. So x squared plus 25 equals 49. So x squared equals 49 minus 25. So x is the square root of 24. And then we also need to think about what quadrant we're in. All students take calculus. Sine is positive. So we can't be here, can't be here. And cosine is negative, so we can't be here. So we're in quadrant 2. In quadrant 2, cotangent, just like tangent, is going to be negative. So we expect our cotangent of theta to be negative, and cotangent is not opposite over adjacent, it's adjacent over opposite. So it's the square root of 24. All right, hopefully you found that very illuminating. Part 2, I will record shortly.